Hi, welcome to part 2 of the video series about physical quantities. In the previous video, we did introduction to physical quantities by defining scalars and vectors. Then we have identified which physical quantities are scalars and which ones are vectors. Finally, we had a look at few multiple choice questions. In this video, first we will learn how to represent a vector. Then we will discuss equality of vectors and negative of a vector. Finally, we will see how to multiply a vector by a scalar. To represent a vector, we are using an arrow. Direction of the arrow is the direction of the vector. The length of a vector reflects its magnitude. The vector on the right side is longer than the one on the left, which means it has greater magnitude. The starting point of a vector is known as tail, and the end point is known as head. We use letters like A, B, F, and so on to name a vector. There are different methods to describe a direction of a vector. In this video, we will learn 3 of them. First, and the simplest one, is relative direction. Direction of a vector may be to the right, to the left, upwards, or downwards. Using compass is another way of representing a direction of a vector. Instead of right, left, and so on, we can use east, west, north, or south. Sometimes vector will not point to any of the main compass directions. In this case, we can use an angle. To express direction of a vector, we need to measure the angle from one of the main compass directions. The angle we measure is 50 degrees to the north from the east direction. So we can simply say the angle for this vector is 50 degrees north of east. We can follow similar steps for the following vector as well. The angle between the west and the vector is measured as 40 degrees. As a result, we can define the direction of this vector as 40 degrees south of west. Third method of representing a direction is bearing. A bearing is a direction relative to a fixed point. Given just an angle, the convention is to define the angle clockwise with respect to north. Let's see some examples. To draw a vector of bearing 62 degrees, we measure 62 degrees from the north and then draw the vector itself. We follow the same steps to draw a vector of bearing 113 degrees. First, we measure an angle of 113 degrees respect to north and then the vector itself. By repeating the steps from the previous examples, we can draw a vector of bearing of 224 degrees and a vector of bearing of 287 degrees. If two vectors have same magnitude and direction, they are equal. As you can see in these examples, each pair of vectors on the screen have the same length and direction. So each pair consists of equal vectors. For all 3 examples, f1 is equal to f2. If either magnitude or directions of 2 vectors are not same, these vectors are not equal. In the first example, directions of two vectors are same, but the second one is longer than the first one. In the second example, even though lengths, magnitudes of these vectors are same, their directions are different to each other. In the last example, neither magnitude nor directions are same. As a result, none of these vector pairs consist of equal vectors. A vector is negative of another one if they have exactly same magnitude but opposite in direction. This is the case for each vector pairs on the screen. Let's have a look to vectors which are not opposite to each other. In the first example, even though directions are opposite to each other, magnitudes of vectors are different. In the second example, their magnitudes are same, but their directions are same as well. In the third example, their magnitudes are different, but directions are also not opposite to each other. As a result, none of these vector pairs are negative of each other. By the way, it's up to us to choose which direction is positive and which direction is negative. By convention, on a horizontal axis right direction and on a vertical one upward direction are accepted as positive. But again, we can decide to choose left as positive and right as negative. In the final part of this video, we will learn how to multiply a vector by a scalar. Multiplying a vector by a scalar means multiplying its magnitude by that scalar. If the scalar is a positive number, the direction of the new vector will remain same. If the scalar is a negative number, the direction of the new vector will be opposite to the original vector. It will be difficult to understand the statements above without seeing them in action. Let's assume that we have a vector A which has length of 4 units. Multiplying it by 2 means drawing a vector with a length of 8 units, as 2 times 4 is equal to 8. We can multiply a vector by a negative number as well. If we multiply 4 by minus 1, we will get minus 4. As we learned in the previous slide, negative of a vector means vector of same length but in opposite direction. So as a result, we have a vector which is 4 units long but points to the left. If we multiply vector by minus 2, we will get a vector of 8 units. 2 times 4 is 8, which is also pointing to the left due to the minus sign in front of it. Not only integers, but scalars can also be real or decimal numbers as well. Multiplying a vector by 1 over 2 or 0,5 will halve its length. If we multiply a vector A with negative 5 over 2 or negative 2.5, the length will become 10 units, as 2.5 times 4 is equal to 10, but direction will be leftwards. As a summary, in this video, we learned how to represent a vector, which vectors are equal and which are negative to each other. Finally, we have looked at multiplication of a vector by a scalar. In the next video, we will learn how to add 2 or more vectors. Thank you for watching, and don't forget to subscribe and turn on the notifications in order to be updated about my new videos.